Welcome back. In this video, we'll talk about a close relative of net present value, internal rate of return. Let's discuss it. There's no mini exercise in this video, but internal rate of return is related to net present value. And really what we're doing is solving for the discount rate. It's actually analogous to finding the yield to maturity on a bond, right? So what discount rate gives the future cash flows a price equal to the cash flow at time zero. Right, so let's see how it looks before we get into that. Like take this project, for example, 10-5. The firm's weighted average cost of capital is 9.5%. Given this discount rate and the cash flows, the project has a net present value of $32.08. Positive NPV project, right? So if this firm's weighted average cost of capital was higher, if the discount rate was higher, the NPV would be lower, right? Because higher discount rates are associated with lower present values. So let's just illustrate that briefly, right? At a 10% discount rate, the project's NPV would be lower, 11%, lower still, 12%. It would be negative actually. And so internal rate of return is the discount rate that gives the project an NPV exactly equal to zero. So rather than do it iteratively like I'm doing, like guessing and checking, there's a function that does it. So let's illustrate how that works. Right? There's no algebraic way to solve this equation for the discount rate, the IRR. Just like there was no algebraic equation to find a bond's yield to maturity, we had to use a spreadsheet program for that. And we'll have to use a spreadsheet program for this as well. So here's a project, and finding the project's internal rate of return is pretty straightforward. There's an Excel function IRR, and I actually like the syntax of this function more than the NPV function. And really, it just takes one argument, the range of cash flows. So equals IRR, that's the internal rate of return function. And you just put in all of the cash flows in the cash flow timeline, including the one at time zero. So you see how that's different from the net present value function where the first cash flow is outside the NPV function. But with IRR, we just highlight all the cash flows in the project. There's an optional second argument, a guess argument to the function, which I always leave blank. So I just include the project cash flows. And so this project has an internal rate of return of 11.39%. Okay, it's another way of evaluating the project. And so in terms of, is this number high? We want projects with higher IRRs, other things equal. And so what's good enough is the answer, right? And what's good enough is the question, right? But the answer is if a project's internal rate of return is greater than the firm's weighted average cost of capital, then we should pursue the project. So IRR and NPV are pretty closely related. Like if we look at this example 10-2 earlier on, we found the project's net present value. It's a positive NPV project, right? And so most positive NPV projects will also have an internal rate of return that's greater than the discount rate, right? So if we compute this project's IRR, it comes out to be 12%. We can show more decimals if we want. 11.65%, right? And so, it's kind of intuitive to think about, is this project worth it, right? Because if the internal rate of return is 11.65% and then the discount rate is 8%, right? On average, a firm's external financing costs 8%. And this project, if we're using investor supplied financing to finance this project is earning a return of about 11.65%. So it's worth it, right? If the IRR is greater than the cost of capital, that's analogous to having a positive NPV project most of the time. All right, so IRR is pretty easy to compute. Some of the things that make it appealing are that it's sort of characterized in terms of percentages, which bosses tend to like. My boss would enjoy something like that. My former boss would enjoy something characterized in terms of percentages. We can use it to compare projects, but I would be wary of that, as we'll talk about in a little bit. And so this is called an NPV profile, and is really just what we did in Excel. Higher discount rates are associated with lower and net present values. And the thing to understand is the IRR is the discount rate that gives a project a net present value that sets the net present value equal to zero. So there's some weaknesses of the internal rate of return. I like NPV better than IRR actually, and here's why. So if the sign of the project's cash flows changes multiple times like they do in this cash flow timeline, this is the first time we've seen this in a project, but it could happen, right? If there's cleanup costs at the end of a project's life or something like that, they could happen, and that can interfere with the the IRR function, right? It can make the NPV profile actually look kind of weird, and there could be multiple discount rates, multiple IRRs associated with it. So if we see the signs change multiple times on a cash flow timeline, we know we should use NPV because IRR could be misleading. Okay, a couple other places where IRR can be a little bit misleading, and it actually comes down to when projects are mutually exclusive. And so this is an important distinction. Independent projects we can do one or both or either, they don't affect each other, right? Mutually exclusive projects, we have to choose between. Right? We can do one, if we have two mutually exclusive projects, A and B, we could do A or B, but not both, right? Maybe we only have enough money to do one of the two, or maybe A and B are two different solutions to the same problem, right? And so we can only do one solution. Like I could build a commercial real estate space on a plot of land or a residential real estate space, but not both at the same time. I guess I could do like a mixed use property, but that'd be something different. Right? So with mutually exclusive projects, the result can be kind of misleading, right? Here's the size disparity problem. Here's a small project and a big project, both with the same discount rate. And then if you find each project's NPV and each project's internal rate of return, you'll find they give conflicting results, okay? And then let's illustrate the same concept with the time disparity problem in example 10-8. Let's check it out. Right? Here's a project whose cash flows occur later in the project, and we can find the net present value, right? Equals the first cash flow plus the NPV function. First argument is the discount rate. The second argument is the range of future cash flows, right? This project has an NPV of 758.83. And then let's find the project's IRR, internal rate of return of this project. Just highlight the cash flows. Nice looking project, right? And then let's do the same thing for project B. Find project B's NPV. Discount rate first, comma, and then the range of future cash flows. Hope you get comfortable using these NPV and IRR functions in Excel. If so, you'll be able to do the assignment without too much trouble. And then the IRR function. We look at this. So NPV and IRR give conflicting information about, draw conflicting conclusions about which one looks better, right? If I'm going by IRR, project B looks better because it has a higher internal rate of return. If I'm going by NPV, project A looks better because it has a higher NPV. So what do? Like when in doubt, if we get conflicting information like this, we should use net present value. It's more reliable. If you have questions or want to discuss further on that, just let me know. So that wraps up internal rate of return. A couple loose ends to tie up in the next video, but we're almost done with chapter 10. Thanks for tuning in.